Good afternoon, everybody. Hope you're all healthy and safe at home. Let us move on to the next module, which is the last module of this course, module 3. And this module consists of two chapters, chapter 3 and chapter 4. So first let us begin with chapter 3. Module 3, chapter 3, dual spaces. So if you all remember, in the last section of chapter 2.3 2.3 we had discussed about the concept of linear functionals, right? And we had also seen that they form a linear space, and we had defined a norm according to it, norm for that particular space. So the space of all linear functionals is called the dual space. So we are given a particular space, a norm space, and we are going to define linear functionals on it. We will be able to define many number of linear functionals. Collection of all those linear functionals will again form a norm space, and that is called the dual space of a space. Okay, and we denote it by X star is the dual of the space X. And also we had defined this norm and we had verified it also. That is, norm f star is equal to supremum x not equal to 0 mod f of x by norm x. And we had seen that there are different forms of this expression also. So this is what is basically the dual space of a given space. We are given a space, the collection of all linear functionals will form the dual space. Now just have a note, or keep this in mind, that is in this chapter, that is in chapter 3, we will be discussing about linear spaces over real numbers. We won't be dealing with the concept of complex numbers, so just keep that in mind. So in theorems and proofs we'll be only dealing with the case of real numbers. Now this is a well-known theorem and very important one. It is the Hanbanagh Theorem. Let's just read the theorem. Let E be a subspace of X and let F dot element of E star. Okay, then there exists an extension F element of X star such that F restricted to E is equal to F dot. So what does that mean? That is, F of X is equal to F dot of X for every X belongs to E. Okay, that is what is the statement saying? It is that if we have a subspace of a given space and if we are defining a linear functional on that subspace, then we can always find a linear functionals in the given space, that is X, such that F and F dot, the linear functionals, will be equivalent in terms of the subspace E. Okay, that is F restricted to E will be equal to F dot. And also there's one more point, that is the norms will also be same. That is, norm of X star, norm f X star is same as norm f dot E star. Okay, their corresponding norms will also be same. So we are actually dealing with the corollaries of this theorem in this chapter. We are not going to go for the proof of this theorem. So just keep this theorem in mind. What is the basic concept of this theorem? That is, if we are having a linear functional in a subspace of a space, we can always find a linear functional in that particular space such that these two linear functions will be equal when we are considering the elements of that subspace. Okay, so just keep this in mind, and we shall be dealing with the corollaries and all in the further next sections and all. So that's it for today's session. Thank you. Stay home and stay safe.